Hello, this is Nitin Dahad with E-Times. I'm having a pleasure of speaking to Rafael Sotomayor, who's President and CEO of NXP Semiconductors. Rafael, hello, how are you?
Good, how are you? Welcome.
Thank you for inviting me to talk to you. And just wanted to sort of talk about stuff that is the trend at the moment, which is physical AI. And I think let's cover in this conversation maybe physical AI and scaling AI. But you've presented this in a sort of a different way, a different perspective of how we should be looking at that enabling of that physical AI. And I think one of those is looking at how we do things with things like neural access. So just explain what you mean by that.
Yeah, well, I think it's a great question to start because the whole notion of scaling physical AI is about solving the biggest problems in robotics today, which is reflexes.
Yes.
As a matter of fact, look at you. You're probably kind of moving. You're quite dynamic, but you're not thinking necessarily.
Float like a butterfly, sting like a bee.
I like that, exactly. And so a lot of the things that you do on a daily basis has nothing to do with conscious thoughts. And so the whole premise is, if we're going to scale physical AI, and probably the most challenging form factor there is in the industry, which is humanoids, we need to kind of look at ourselves and say, okay, how do we mimic intelligence in our own body? And the whole concept was that if reflexes dominate your daily lives in a way that you do it without really thinking about it, with very, very little cost of energy, then you need to kind of replicate the same thing for physical AI and robotics. And so the notion of a neural axis is that you not necessarily scale physical AI by putting a bigger brain, you scale AI by putting intelligence in the right place. Yeah. Which means that there's three layers of intelligence. You have the reasoning layer, which in a human body, that will be the part of the brain, it's called the cerebrum.
Yes.
You have the coordination layer, the ability to actually manage your motor controls, your posture, your balance, and that is part of the cerebellum. So we mimic that in a physical AI by putting the coordination layer. And then anything that has to do with reflexes, actually a week from now is a World Cup. And so the ability to actually be able to react, be able to jump, something that is super quick, super fast, that is called what we call the reflex layer. And each one of them has different attributes. Reflex layer emphasizes latency.
Yeah.
Reasoning and deliberate conscious thoughts emphasize deep AI. And so there's a spectrum with respect to what makes a humanoid actually useful. And that spectrum is super important to observe because one size fits all doesn't work.
Yeah. I mean, it was quite interesting in your Computex 2026 keynote in Taipei. One of the headlines I saw afterwards was Rafael Sotomayor says you should react before you think, because he's talking about that quick reflex.
Right.
And I think it's kind of plays to a lot of what you've been doing for a long time, which is that edge intelligence, getting it right, and then putting all those different things in different places, in the right places.
Right. Well, the whole concept, I didn't say, by the way, from everybody here, I didn't say react before you think. You should always think.
That was the headline. I think.
What I meant to say is that I think the level of intelligence that we have in the body, in order for us to be safe, we sometimes have to react faster than we think, because the ability to actually be safe in a world environment, it has to be about making sure you deal with the environment faster than you're able to understand what's happening with the environment. And I think when you apply that to robotics, is very relevant. The ability to actually a robot to be able to stumble and recover without having to go to the cloud and kind of run a very complex model, that intelligence needs to reside with the body itself. And that requires a different type of solution versus the ability to actually really understand a very complex problem.
And, I've been covering NXP with a lot of what we've been doing in automotive and, the autonomy and all that. And I think there's a lot of what you've done there, which can actually be translated to the humanoid robotics and physical AI. There's quite a lot you can take from that.
Oh, absolutely. I mean, what is self-driving car but a robot, right?
Exactly. Yeah.
And so, and by the way, the notion of a neural axis in the car is still, kind of really applicable.
Yes.
You still have the reasoning layer with ADAS, right? With navigation, with trying to understand what the car is going to do next. the coordination layer fits very well what we're doing with this
The zonal
product.
control.
Well, actually, the central compute process will manages vehicle dynamics, right?
Yeah.
This is our 5 nanometer S32N product that we have. They're quite, quite powerful and it really created a leadership position for NXP. And then now you have the reflex layers at the end doing this safety critical applications like braking, like suspensions, things that need to act super fast. And that's your zonal control application. Yeah. So if you can see the different layers of intelligence, you can see that it applies very nicely with a neural axis concept, but there's always a level of intelligence in every layer. What I want, the takeaway is that not all the intelligence goes to the reasoning layer, to the ADAS chip. Each layer requires certain level of AI to be fit for purpose. Correct. With the latency and the power requirements that function requires.
And that applies when you're trying to scale AI as well, I guess. So you need to make sure you're still making those layers fit for purpose.
Absolutely. I mean, just now go back to the human example. The human needs to have stable motion, stable movements. But the robot over time will continue to learn. It will continue to learn new use cases, to be able to adapt, and maybe you go in and do certain applications. But during the process of learning and evolving this use case for the robots, your motion control needs to stay always stable. And so that kind of tells you the reason why the separation is so important.
So what's exciting you these days?
Well, the journey that we're in.
Yeah.
Right? I mean, it's actually, you get to see kind of the transformation that is happening. All the assets that we have, they're very relevant for industrial, for automotive. All the assets of real-time performance, all the software and the chips and the solutions that we have for automotive, you can see the transferring to actually very, very nicely into robotics. All the assets that we have on perception and sensing, they're very applicable with what these new devices and physical AI are going to do for the next decade. So this journey that we're in with NXP is quite an exciting one.
And it's an exciting time at the moment, isn't it?
It's just fascinating. It's just, I told yesterday in the keynote that we're living through probably the largest technology evolution ever, where we seem to kind of have some amazing announcement or press release almost hourly. It's really hard to kind of keep up. Yeah. But it's also a confirmation that it was what's happening. Their deployment of AI models from the cloud to the edge are creating massive impact in terms of value creation, and it's going to change our lives.
And it's not all about tops.
It is definitely not all about tops. It's not about the big brain. It's about putting the right intelligence at the right level to be able to get the use case that you want to get from your robotics. Because robotics, especially in the next 5 years, is going to be about use cases, about return on investment, and then not all of them are going to be the same form factor. There's going to be different shapes that you're going to see on these autonomous devices.
Yeah, I've been into a store at Christmas in London, and I saw so many different ones, all from Japan.
All from Japan?
Yeah.
Well, I think you're going to see a lot more here in Taiwan.
Yeah. Well, Rafael, it was nice talking to you again.
Fantastic. Thank you.